Whether you use a dollar bill, a spoon, or a shoe, you know that opening a bottle can sometimes be difficult. With a force gauge, you can even see that it requires about 114 newtons of force. Using a pretty respectable 7-inch bottle opener, it only takes about 16 newtons of force. But as a lazy human myself, I figured why not take this mechanical advantage to the extreme and see if even a banana can open a bottle. The concept of mechanical advantage is rather simple. To generate the required moment with less force, you can push from further away from the fulcrum. Then this moment is translated to the shorter moment arm, meaning the tooth pushes with more force and actually pops it open. Putting numbers to this, you get a required moment of around 104 newton inches. And I know that's an infuriating unit, but it will work just fine. Before we move on, I need to point out that this simple calculation is actually missing something. Although it won't have a huge impact in this case because the angle is small, you need to use the component of the total force acting perpendicular to the moment arm, not the total force. If you don't see why, think of it like this. If I push on the bottle opener like this, I may be exerting force, but it's not contributing to any rotation. I need to only use the force acting this way. To account for this, I can use simple geometry to separate the components of the force into the force acting perpendicular and parallel to the moment arm. And then I'll only use the component acting perpendicular for the calculation. After this adjustment, the required moment to open the bottle is now about 97 newton meters. For the longer 31-inch bottle, if you do the same calculation but this time solve for the force needed to achieve the required moment of 97 newton inches, you can get a completely wrong answer. That's because of something overlooked completely so far, which is the fact that the weight of the bottle opener itself already creates a moment. The weight of a single bottle opener is 72.5 grams, which has the minimal effect of only 2 newton inches when using a single bottle opener. However, for 7 bottle openers and glue weighing 514 grams total, and incorrectly assuming they are equally spaced for simplicity, you get that the weight contributes to a moment of 70 newton inches. Subtracting this moment from the required moment measured earlier, and you'll find that you only need an additional moment of 29 newton inches to open the bottle, which by my calculations means that a single banana should be plenty of weight to open the bottle. That's the theory, but let's look at it in practice. Before committing to gluing all 7, I first glued 5 together to see how the bottle handles it, and sure enough, the glue wasn't quite dry. Regardless, it looked promising, so I committed to all 7 and made sure that the glue fully cured. The bottle held this up well, and it was extremely easy to open, so it was time for the banana test. But sadly, when I was reaching for the banana, the bottle lifted up a bit, and that little additional acceleration as I returned the bottle to be flat on the table was enough to open the bottle on its own, resulting in the loss of 2 bottle openers. Even with this loss though, I was happy to report that it still passed the banana test. Thanks for watching to the end, and I'll see you next time.